All right, so we're going to look at integer exponents. Now, what is an integer again? Oh, that's right. Our positive and negative whole numbers, including 0. We looked at that in the unit before. So if you need to review that, go back to the previous unit and look over a couple of things. Because integers are never going to go away. That is how we have our fractions. We take two integers and we divide them, and that's how we get our fractions. So, why are we talking about integers again, though? Why didn't we do integer exponents when we looked at integers? Because it was not the appropriate time. Because integer exponents yield fraction answers. You will see what I mean in one moment. Here we go. So in the first example here, we have 2 to the power of negative 3. Now, if this was 2 to the power of 3, or 2 to the third power, you would tell me just to multiply 2 times 2 times 2, and that would be it. Well, we're going to do something very similar here. So what does a negative exponent actually do? Well, a negative exponent tells you to take the reciprocal. We use that word when we're doing dividing fractions. Reciprocal means to flip it. So 2 as a fraction, as we talked about when we looked at multiplying fractions, is really just 2 over 1. So this negative tells us that we're going to flip this fraction. So this is going to be 1 over 2 to the third power. Notice how the negative is no longer in the exponent? Well, that's because we've already done what that negative wants us to do. And all it wants you to do is, once again, to flip the fraction that's here. There was no fraction. You made that into a fraction. Well, as I said before, every number that can be written as a fraction is a rational number. And in other words, all integers are really fractions. We can just put them over 1. We can also change the way they look by using equivalence fractions. All right, so let's finish this problem. So we have 1/2 to the third power. That means we're doing 1/2 times 1/2 times 1/2. And we get 1/8. So 1/8 is our answer. All right, good job. Now, let's say that instead you started off with this 2 to the third. Well, 2 to the third is 2 times 2 times 2, and we get 8. Then all we had to do was worry about the negative portion of the exponent, which we now know means that we flip that fraction. So if we flip 8 over 1, we would end up getting 1 over 8, which is what we got as our answer. So it didn't matter if we flipped the fraction first or if we did the power first? No, it didn't. Many people find it easier to take care of the negative part first, negative part of the exponent first. But again, it does not matter because this is all together. This negative 3 is all together. Okay, so let's look at another example here. So we have negative 2 to the negative 2 power. Ooh, a lot of negative 2's here. Well, if we start off by flipping our fraction, this is really looking at negative 1/2 to the second power. Again, we could have taken care of the power first, which would have been fine, but I'm going to stick to taking care of the negative first so that you can see the fraction, and because we're working with fractions. So negative 1/2 to the second power would be negative 1/2 times negative 1/2. All right. Well, as we saw before, negative times negative gives us a positive, so this will be a positive. 1 times 1 is 1, 2 times 2 is 4. So this would be a positive 1/4. All right, simple enough, positive 1/4. Okay, what about if it starts off as a fraction? Still the same, we flip it. So 1/2 to the negative third power, we would flip the 1/2, so this would become 2 over 1 to the third power. In other words, this is really just what's 2 to the third power, which you all have already done today, and that was 8. Okay. Well, negative 1/2 to the negative first power. So negative 1/2, we flip that fraction, we get negative 2 over 1 to the positive 1 power. And anything to the first power is just going to be whatever the base is. So we end up with negative 2, because negative 2 divided by 1 will just give us negative 2. And that's it. Now I'm going to show you one other way to kind of get a better understanding of what is happening with these negative exponents and where they come from and how you would visualize that. So we're going to use the number 2 just because that's easier for most people when looking at. It's easier for most people when looking at exponents. So let's start off with what is 2 to the first, 2 to the second, and 2 to the third. And we'll also look at going the other direction. What's 2 to the 0, 2 to the negative first, 2 to the negative third, or negative second, and 2 to the negative third. Okay? Well, 2 to the first, as we already say, anything to the first power is just itself, so this will be 2. Okay? 2 to the second would just be 2 times 2, which would be 4. 2 to the third would be 2 times 2, which we said was 4, times 2 more, which would be 8. So notice each time we increase this direction, we multiply our previous answer by 2. Well, that makes sense because the exponents multiply by the same number. All right? Well, what if we went the other direction? Well, if we look at this going the other direction, going from 8 to 4, you're dividing by 2. Going from 4 to 2, you're dividing by 2. So 2 to the 0 would be whatever 2 is divided by 2. So 2 divided by 2 would be 1. Because anything to the 0 power, if you remember from first time we looked at powers and roots, anything to the 0 power is 1. With the exception of 0 to 0, we don't do that. All right. 2 to the negative 1 then would just be whatever 1 divided by 2 is. And 1 divided by 2 is 1 divided by 2, or 1/2. Okay. What if we didn't divide it 1/2 by 2? Oh, let's see. 1/2 divided by 2. Well, remember when we were doing division with fractions? We have 1/2. Change the sign to multiplication. And flip the second fraction. That's not a fraction. Yes, it is. This is the same as 2 over 1. So if you flip that, we get 1/2. And so we get 1 times 1 is 1. 2 times 2 is 4. Our answer of 2 to the negative second power would be 1/4, which we saw earlier when working with this. So the last one would be 2 to the negative third. And you guessed it, we would just divide by 2 again. And I'm sure you see the pattern by now. You would end up with 1/8. That was the first example we looked at anyway. Okay. So if you ever get confused when you see a negative exponent, just go back to this example. Well, what would it look like if I started by taking that number to the first power, to the second power, to the third power? Now, what if I went the other direction with it? I would have to be dividing by that base. And as I divide by that base, it becomes more simpler to see that all we're doing is changing this into a fraction or flipping the fraction. Because if you flip it going the other way by doing a negative times a negative, making it a positive, that would still be taking it to a negative exponent. That would flip this and we would get up 8. All right. So that is integer exponents. So when you have an integer exponent, you still raise to the power, whatever the power is. The only difference is if you have a negative exponent, you have to change it to the reciprocal or flip the fraction. See you soon.